Hello, ASTR people. So let's talk about the last coordinate transformation between systems that I'd like to talk about, the conversion from equatorial coordinates to galactic coordinates. Galactic coordinates are useful when you want to refer to objects in the galaxy or with symmetry with respect to the plane of the galaxy. What we're seeing here is the plane of the galaxy on the night sky. You cannot see the equator, the celestial equator in the night sky. You cannot see the ecliptic on the night sky, but you can see the galactic circle. Galactic coordinates are useful, for instance, when studying open clusters. You see here distribution of open clusters, and you can see that they cluster around the plane of the galaxy, right? They cluster around galactic latitude around the galactic circle. So to pass from equatorial to galactic coordinates, what you do is the same thing that we did before. You have the vernal point in here. You go from the vernal point along the celestial equator to the vertical circle of the star, and that's the right ascension. And then from the equator to the star, there's a declination. For galactic coordinates, you start from the galactic center to the vertical circle from the galactic circle to the star to the galactic pole, and that is the galactic longitude. And then from the galactic circle to the star, that is a galactic latitude. We refer to these coordinates by the letters little l and little b usually. And one important point is the ascending node, which is the intersection between the celestial equator and the galactic circle. It's like the vernal point between the celestial equator and the ecliptic, but it's between the galactic circle and the celestial equator. So let's draw the triangle that is going to help us convert between the coordinates. You have here that the triangle is the one defined by the star, the north celestial pole, and the north galactic pole. So let's do the trigonometry for this triangle. So the elements of this triangle are, you go from the celestial pole to the star, that's 90 minus declination. From the north galactic pole to the star, that should be 90 minus the galactic latitude, little b. And between the north galactic pole and north celestial pole, that's the inclination between the celestial equator and the galactic circle, called that I. As for the angles, we have to make use of the ascending node. So you can pass a vertical circle from the north celestial pole to the ascending node. And this here is the right ascension of the ascending node. Therefore, this angle here is the right ascension of the star minus the right ascension of the galactic node. And this is a right angle. So this angle here, with vertex at the north celestial pole, is 90 plus alpha minus alpha omega. Now this other angle here, with vertex at the north galactic pole, it's going to be given by the ascending node. But we now pass to galactic coordinates and go from the galactic center to the ascending node. That gives you the longitude of the ascending node. If you pass a vertical circle going from the north galactic pole to the ascending node, then you have that this angle here, this side, is the longitude of the star. So what you have here is the longitude of this star minus the longitude of the ascending node. So that should be this angle. This is L minus L omega. And this angle here is a right angle. So what is left is 90 minus L minus L omega. So this becomes 90 minus L minus L omega. So if you apply the fundamental law of cosines to this, what you have is sine B is equal to cosine I sine delta minus sine I cosine delta sine alpha minus alpha omega. If you apply the law of sines, you have cosine B cosine L minus L omega is equal to cosine delta cosine alpha minus alpha omega. And applying the arc and angle formula, you have cosine B cosine B sine L minus L omega is equal to sine I sine delta plus cosine I cosine delta sine of alpha minus alpha omega. So if you know the inclination of the galactic circle with respect to the celestial equator, the longitude of the ascending node, and the right ascension of the ascending node, you can pass from galactic coordinates to equatorial coordinates. The opposite transformations would be given below. And the coordinates of the ascending node are in galactic coordinates. The longitude of the ascending node is 33 degrees. By definition, the latitude is 0. And in equatorial coordinates, the right ascension of the ascending node is 17 hours and 46 minutes. And the declination is minus 29 degrees. The inclination of the galactic circle is 62 degrees and 36 minutes. So these complete the coordinate transformations.